Hey y'all, since we didn't get to do this in class, I just want to make sure that we do this question as well. We did the one in the homework was really similar to this, but I missed this page in the class, so I just wanted to do this for you right now. So I want to find the force on particle 3. I like to first just draw a coordinate system on that particle, and then I can draw a triangle here that shows me the various distances. Now, um, I recognize here that this distance, this is a 3, 4, so the hypotenuse of this triangle is 5 meters. And then I'll also want to know what this angle is. I'll call that angle theta. By the way, that 5 meters I got from the square root of 3 squared plus the square root of 4 squared, that's equal to 5. That's just from my Pythagorean theorem, a squared plus b squared equals c squared for that right triangle. And then to find the angle theta, that's going to be the inverse tan of opposite over adjacent. That's the opposite, that's the adjacent side, so 3 over 4. And so that angle theta is, was it 37 degrees? 37 degrees. So I'll need to figure out those just right away, the distance to that charge and then that angle. Then I can also draw my my vectors. The force on particle 3 due to particle 1 is going to be up and in this direction. I'm going to call that F31. That's because those are like charges and they repel. And then the force on particle 3 due to particle 2 is going to be in that direction. So that's F32. Also recognize here that this angle is equal to this angle, which we said was 37 degrees. So that's 37 degrees right there. So that's my first step, is just to make sense of all the forces that are acting in this, draw my coordinate system and determine the angles. I also determine this distance to that charge using the Pythagorean theorem. The second step is I want to determine what are the magnitudes of those two charges. So F31 is K Q3 Q1 over R31 squared. That's going to be that 5 meters. And if I do that, I get that force, if I put in all the right numbers, is 1.08 times 10 to the minus 9 newtons. And then likewise, F3, that should be 3.2, the force on particle 3 due to particle 2 is going to be equal to 1.13 times 10 to the minus 9 newtons. So those are the forces acting, the magnitudes of F31 and F32. You can take a moment if you like and just make sure that you know how to put in the numbers and get those values for that. So that's the second step. The third step is to find the x and y components of any vector that is off axis. In this case, that's going to be F31. So I want to find F31x and F31y. The x and y components of that vector, which is off axis, that's F31. This is going to be F31, the magnitude, times the cosine of 37. That's this number times the cosine of 37. Okay, so that F31 cosine of 37, that is equal to 8.63 times 10 to the minus 10 newtons. And then likewise, or similarly, F31 sine of 37, that is doing this number times sine of 37, gives me the y component, which is going to be 6.5 times 10 to the minus 10. Just make sure that you can get those same numbers, that you understand what I'm doing there. Now at this point, I like to redraw my vectors, because I've now resolved that one vector, and I can put them here. I have F32, that is that 1.13 times 10 to the negative 9, and then I have F31y right here. Or excuse, yeah, this is F31y. That's 6.50 times 10 to the minus 10 newtons. And then this is F31x. That's 8.63 times 10 to the minus 10 newtons. All right, so I like to do that. It just helps me to think about the vectors. So we could call that step 3b, just to redraw that coordinate system. You might not do that on the exam, but I find that it's helpful while you're learning. And then step 4 is to take the sum of all the vectors, the sum of the forces in the x direction. That's going to be 8.63 times 10 to the minus 10 minus minus, because this vector is in the negative direction, 1.13 times 10 to the minus 9 newtons. And that gives me the component in the x direction, which is going to be negative 2.67 times 10 to the minus 10 newtons. It should be negative, right? Because this number is bigger than that number, and so that net x vector is going to be in the negative x direction. And then I can do the same for y, but there's only one vector in the y direction, so it's just 6.5 times 10 to the minus 10 newtons. Okay, so now I have the x and y components. I'm going to draw them here, but I'm going to draw them in a different color. So I have this vector, which is in that direction, and then that vector, which is in that direction. That is the x and the y component. One is in the x direction, and then the negative x direction, and the other is in the positive y direction. Now, finally, for step 5, I find the magnitude and direction. That is the magnitude and direction of the vector that is in this x quadrant, in the second quadrant. I'll call this the angle phi. First, to find the magnitude of that force, I say the square root of fx squared plus fy, should be a y, squared. That's going to be this number squared plus that number squared. You can leave the negative there if you want, but it's a squared number, so it goes away. And I get 7.03 times 10 to the minus 10 newtons. And then the angle phi is going to be the inverse tan of fy over fx. That's the inverse tan of this number divided by this number. So it depends on your calculator as to whether or not you include that negative. Most calculators are not smart enough to determine the quadrant that you're in. So what I generally tell students is just leave off negative values and go by the figure that you've drawn here. And if I do that, I find that that angle is 67 degrees. But then I have to add another qualifier, 67 degrees above the negative x-axis. However, there are some other correct answers, or there's really one other correct answer, and that is that it could be, what would that be, 113 degrees from, or you could say above, but I would say from the positive x-axis. That is this angle right here. If this is 67, that's 113. I just do 180 minus 67. Your calculator, if it's smart enough, might give you this number if you put in the negative for the x component. So if you make this number negative, it might be smart enough to tell you that and give you 113 degrees. But the problem is if you put it in the y component, then that puts it down in the fourth quadrant, right? My advice to you is whenever you're determining angles, you just leave any signs off of there, off those x and y components, and then just use the figure that you've drawn to determine that. It does matter, okay? So on the exam, when you have this free response, I will be looking to see that you have the resultant vector in the correct quadrant. If you've had 101, which all of you have, this shouldn't be new to you. We've done this. So hopefully this will just require a little bit of jogging your memory about how to add vectors in 2D. But it is important, and I want to see that you know how to add vectors in 2 dimensions. It is something that I expect you to do before you move on past this course into the wide world. Okay? We'll do this again with electric fields. Actually, for your exam, it will have field vectors in 2 dimensions, which are actually a little bit easier than force vectors, and we'll do an example like that in class.